Let's start with the science that gives us renewable sources. You see, we have all these amazing resources our planet gives us: sun, wind, water that produces natural energy. By harnessing this natural energy to create electricity, we can reduce carbon dioxide emissions associated with traditional electricity generation and slow down climate change. Let's look closely into the different technologies for producing renewable energy. Let's first look at wind power. A wind turbine uses the airflow captured by its blades to turn a generator, producing electricity. Horizontal axis wind turbines are the most common type of wind turbine. They look like the propeller blades from a jet engine. They are large and designed to face the wind. Vertical axis wind turbines are less common, and although they are less efficient than horizontal wind turbines, they are more flexible. Vertical wind turbines can capture wind energy from any direction, and wind farms of this type can be densely populated as their airflows do not interfere with each other. Wind turbines can be installed on land and offshore, and currently, wind energy constitutes approximately 1% of the global electricity output. Some people even install them in their gardens.
Solar photovoltaics is about taking the sun's energy and converting it into electricity. Typically you would see them on buildings as what we would call solar panels. And solar is great because we already have a huge nuclear reactor in the sky that we use the sun. What we need to do is harness it and use it properly.
When rays of light strike the surface of a photoelectric material such as silicon, electrons are emitted from the surface. These electrons generate electrical current as they leave the photovoltaic cell. Only light of certain frequencies can cause this process to take place, which is why most solar panels only work with direct sunlight, not artificial light. Typical solar cell efficiency is around 15 to 20%. However, newer types of solar cells can reach efficiencies up to 42%, a very promising advancement in solar PV engineering. You can find solar PV on south-facing rooftops, in solar farms, and even in space, thanks to pioneering Welsh engineering firms.
A big challenge in the whole PV industry is the efficiency of the solar panel. And so when we're talking about taking this centimetre squared up to what we currently work on, which is 30 by 30 panels, you get an efficiency drop purely because it's bigger. It's the way it is because we have factors to think about, such as printing consistency, the infiltration of the perovskite, and getting that uniformity of the panel itself.
The other thing is that you can also combine it with other technologies. So for example, when the sun was powering a solar panel, the solar panel gets warm. And there is a way where you can actually use the sun's energy to also derive heat from the solar panel. And that's combined solar thermal technology. So at its core, solar thermal relates to using the sun's energy to produce heat that you can capture and do something useful with.
Tidal power creates a renewable source of energy through a predictable pattern of ocean waves. There are different ways of harnessing wave energy, such as tidal streams, barrages, and tidal lagoons. When a wind turbine is placed in a stream of fast-flowing water, it converts the energy from the movement of water into electricity. This is known as a tidal stream. And whilst it can work with any fluid, the energy generated from water is much greater than wind because water is a more dense fluid. A tidal barrage is a long, straight, man-made dam that captures energy from water moving in and out of a bay or river due to tidal forces. Tidal lagoons work in a similar way to tidal barrages, except that they enclose an area of coastline with a high tidal range behind a breakwater. The advantage with tidal lagoons is that they are designed to minimise environmental impact, and even create micro-habitats for small fish and birds to thrive. Wales is a pioneer in the field of tidal energy, with plans for a 320 megawatt lagoon, floating homes and a climate change research centre planned for construction in 2023. Despite all the benefits of renewable energy, lots of challenges still exist for engineers to solve. The first challenge is the availability of renewable energy. Most solar PV cells require daylight to function, whilst wind turbines need an optimum wind level. That's right, not enough wind results in poor generation, whilst too much wind can damage the turbine. Another problem is the efficiency of renewable energy generation and the carbon footprint of the manufacturing processes themselves. For example, a solar panel can take several years of energy generation to counteract the carbon footprint created by manufacturing and transporting it to its end destination.
The current business model when we're manufacturing is a very linear economy, and what that means is we tend to dig stuff out of the ground, we make things, and at the end of their life we throw them away. And that's really wasteful. There's only a limited supply of these materials on this planet. So thinking about reusing products or recycling them and taking those materials and either making other products or perhaps making those products last much longer.
For engineers, this poses an important and pertinent challenge. How can we maximise the efficiency of renewable energy, reduce the impact of manufacturing processes, and localise supply chains to achieve net zero faster?